Welcome back to the video lecture series. I am Adil Mansoori from Civil Engineering Department of LJ Institute of Engineering and Technology. Okay students, so today we are going to start with the new module, and today's topic of discussion is distribution system. Up till now we have covered the different treatment units of the treatment plants. Okay, now what after the water has been treated and it is stored in the underground reservoir. Okay, so the next hierarchy or the next process is to distribute the water into the different areas. Okay, so let us start. So the first question that might arise in your mind is, what is a distribution system? So as I said, after giving complete treatment to the raw water which has been extracted from different sources, the next step in the water supply scheme is to supply the treated water to the consumers. Okay, so these consumers may be in domestic area, in commercial area, or the industrial area. Now in a year where there may be requirement of firefighting, okay, so the function of firefighting has to be also satisfied. Now the function of carrying water to its destination is accomplished through a well-defined network of distribution system, and the performance of the distribution system can be judged on the basis of the pressure available in the system for a specific rate of flow. Okay, now the next question that might arise in your mind: are there any components of the distribution system? So the answer is yes, there are various components of the distribution system. Let us have a look at it one by one. So the first component is pipelines of various sizes. The main function of the pipelines is to carry the water. In the market, the sizes of pipelines that are available varies from few millimeters to few meters. Okay. Next component is valves. The main function of the valve is to control the flow. The various types of valves that are available in the market include line valves, air valves, sluice valves, air release valves, butterfly valves, air inlet valve, globe valve, needle and cone valve, check valves, and screw valves. All these valves have different functions. Okay. Next is hydrant. The main function of the hydrant is to provide water during fire. Okay, so these hydrants are usually placed on the sides of the roads at a particular interval. Okay, next is service and storage reservoir. The main function of the service or storage reservoir is to store the treated water. Okay, so we all know that after the water has been treated in a treatment plant, which are designed for few million liters of water to be supplied per day, right? So the water which is treated is now stored in an underground tank which is known as the storage reservoir. Okay, so next is the flow measuring devices. Okay, so the flow measuring devices are useful for measuring the quantity of water that is released from the treatment plant, and also the quantity of water which is used by the end users. Okay, so flow meters are used for measuring the quantity of water either discharged or utilized. Okay, so these are the few components of the distribution system. Now another question that might strike in your mind: what are the requirements of the distribution system? So there are few requirements of a good distribution system. So the first requirement of the good distribution system is that it should be capable of supplying water with the sufficient pressure. We all know that a particular city or a town is spread in few kilometer square of area. Now we know that the treatment plant may be few kilometers away from the end users. Okay, now when you supply the water from the treatment plant at a particular pressure, then the end user who is a few kilometers away should receive the water with the same sufficient pressure. Okay, otherwise his needs will not suffice. Next is the distribution system should convey the water with the same degree of purity. It means that the distribution system should be such that all the joints of the distribution system should be sealed or watertight, so that any other kind of foreign particle should not enter the distribution system, and the end user will get the water with the same degree of purity, the degree of purity which is supplied from the treatment plant. Okay, next is all the joints of the water distribution system should be watertight. Okay, next is supply requirement of water for firefighting with sufficient pressure. It means that the distribution system should be capable of providing sufficient quantity of water with sufficient pressure in case of any fire accident for dousing the fire. Okay, next is as low as possible the initial cost should be, right? Next is it should be easy to operate and maintain. Clear? Next requirement is that it should be reliable during breakdown and repair. That is, for example, if a particular area gets affected by any breakdown or leakages, right, then only that particular area should be affected, and the rest of the area should get the water with sufficient quantity and pressure. Other areas should not get affected. Okay, next point is that it should be safe from the future pollution. It means that we know that both the system, that is the sewerage system as well as the water supply system, are laid underground. Okay, and in order to avoid contamination from the leakages of the sewer system and to avoid the entry of the foreign particle into the water supply system, we should take care that both the systems are at least 1 meters away from the each other. Okay, next is it should not be laid below the sewer line. Okay, the distribution system should not be laid below the sewer line. Next is that the good quality of pipeline must be used such that it does not get burst. Okay, because we know that when you pump water from the treatment plant, the pressure of the supply is extremely high. Okay, so the quality of pipeline should be better so that it do not get burst. Okay, now the next question that might arise in your mind is are there any specific types of networks? So the answer is yes, there are different types of distribution network. Let us have a look at it one by one. So the first one is known as the dead end or the tree system. Second one is known as grid iron or reticulated system. The third one is known as ring or circular system, and the last one is known as the radial system. So these are the four different types of distribution network. Okay, so let us have a look at it one by one in depth. So the first one is dead end system or the tree system. So this system is suitable for irregular growing town. Okay, it means that the dwelling houses or the colonies that are being established are in an irregular way. Okay, or only a particular area is getting developed and other area is not getting developed. Okay, next is in this system there is one main pipe which starts from the reservoir and it moves along the main road. That is, one main pipeline is supplied along the main road. Okay, next is the sub mains are connected with the mains in both the direction of the main road. Okay, next point is that sub main divides into branch pipes which are known as laterals. Okay, and last, laterals to the consumers are connected with the help of service connection. Okay, so I'll show you the picture so that you'll get a better clarity. You can see over here that there is a black line in the center, which is the main pipeline. Okay, and it is along the center of the road, right? And on both the sides of the main pipeline there are sub mains. Okay, then sub main is supplied or connected with the laterals, and after the laterals there are service connection at the end points. Okay, or the at the dead ends. Okay, so this is how the dead end system works. Let us have a look at the advantages of this system. So the first advantage is that the network can be solved easily, and calculation of discharge and pressure is also easy. Okay, so you can find out that only certain quantities of houses are there, so you need this much quantity or a particular quantity of water to be supplied in that particular area. Okay, next is the this system is cheap and economical, and laying of pipeline is simple. Okay, there are less cut-off valves. Okay, so next is what are the disadvantages of this system? So the first disadvantage is that water is supplied in only one route. So if repair work in any pipeline is carried out, then all the houses of that particular area will get affected. Okay, next is stagnation of water and sedimentation takes place at the dead end. Third point is that large number of screw valves are to be provided at the dead ends in order to remove the sediments. Okay, next point is that supply during the firefight cannot be increased. So the next is less pressure is available in at the end of the system. Okay, so these are the few disadvantages of the dead end system. Let us now have a look at the gridiron or the reticulated system. So this system is convenient for towns having rectangular road systems, and this system is considered as an improved version of the dead end system. Okay, all dead ends are interconnected, and hence water circulates freely throughout the system. You'll get a better clarity when I show you the figure. So you can see over here that there is a main at the center. Okay, and on both the side of the main there are sub mains, and dead end connections are interconnected. Okay, so this is an improved version of the dead end system. Okay, so there will be continuous circulation of the water in each of the pipelines. Okay, so let us have a look at the advantages. So first advantage is that dead ends are eliminated, so there will be constant water circulation. Okay, so there will be no stagnation. Okay, so frictional losses and pipe sizes are reduced. Next is there are very small area affected if the particular area needs repair. Okay, next is wildfire, more water can be delivered. Okay, so if any area catches fire or any place catches fire, then more area or more water can be delivered to the place of fire. Next is what are the disadvantages? So the first disadvantage is that there are more long pipes and more sluice valves needs to be installed for regulation of the water supply. Okay, next is difficult design. Why difficult design? Because water is in continuous circulation, so how much quantity of water will be supplied, that calculation becomes difficult. Okay, since more sluice valves are there, there will be costly construction. Okay, and analysis is difficult because you don't know how much quantity of water is supplied or it is flowing through a particular pipe. Okay, so next is ring or circular system. This ring or circular system is a closed ring in a circular or rectangular shape, and main pipe is formatted around the requirements of the area. Okay, area is divided into circular or rectangular blocks. Main pipe is on the periphery of the block. Branches and sub mains are laid along the inner roads. The advantages and disadvantages are same as the gridiron system. Okay, so let us have a look at the figure. So you can see over here. Okay, this is the figure of the ring system. Let us now move for the radial system. So this system is suitable for radial road layout. Okay, so if a particular city has a radial pattern of population growth, then this system is most suitable. This system is a reverse of the ring system. An area is divided into number of zones. Distribution reservoir is at the middle of each zone. Supply pipe laid radially ending towards the boundary of the area. Okay, so you can see over here in the figure that main pipeline is at the center. The area is divided into zones. There is a reservoir at the center of each zone, and there is only one inlet which is leading from main towards the reservoir, and from the reservoir the water is supplied radially towards the ends. Okay, so this is the radial system. So let us now start with the next topic, and that is the methods of water distribution. So the first method of water distribution is gravity system, in which the water will flow through the gravitational force of the earth. Okay, next is the pumping system, in which various pumps of various capacities will be used for pumping the water. Okay, and the third one is the combined gravity and pumping system, or which is also known as the dual system. Okay, so let us have a look at each of these systems in detail. So the first system that is there is the gravity system. So this system is suitable when reservoir is at sufficient height than the city. More reliable and economical because no need of pumping, right? Why? Because once the water is supplied from the treatment plant, it is supplied to the reservoir at a particular location, and then the water is supplied with the help of gravity system. Okay, this system is so designed that available water head is just minimum required and remaining head is consumed in friction and other losses. So the next is pumping is required for fire demand. So in case of fire demand exists, then we need to pump the water. Okay, so let us have a look at the picture. So there will be a reservoir which will be at the top as compared to the city. It will be at a higher elevation, so the water will flow with the help of gravitational force. Okay, so this system is known as the gravity system. Next system is the pumping system. So the treated water is pumped into mains without storing it. Okay, and high lift pumps are required, which are operated at variable speed to meet variable demands. Okay, next is constant watch is required at the pumping station. If damage or failure occurs, and if stoppage of supply occurs or if fire occurs, then this pumping system is a real disaster, and therefore this system is not used nowadays. Okay, so once again, the water is pumped without storing. Second point, high lift pumps are used which which are operated at variable speed. Next, constant watch is required at the pumping station, and if any failure or damage occurs or any fire accident occurs, this system is not going to work. Okay, let us have a look at this picture. So pumped supply system, that is, water will be taken from the reservoir or the source and it will be directly supplied to the city without storing in the elevated reservoir. Okay. Okay, next is the combined or the dual system. So most ideal and widely system is the combined and the dual system. Okay, so water is pumped at a constant rate and is stored in a reservoir of a particular area. Then after the requirement arises or when the demand arises, then the water is distributed using the action of gravity. Okay, next is pumping and distribution is done simultaneously, so that excess water stored while low demand and it can be used during high demands. Okay, let us have a look at the picture. So this is the picture of the dual system of supply. Let us have a look at the next topic, that is the clear water storage reservoir. So it is essential for storage of filtered water till it is pumped. We all know that once the water is treated in the treatment plant, it has to be supplied, but before supply we need to store. So next is, it has the capacity to store the water quantity corresponding to 14 to 16 hours of the average daily flow for storage. It means that we all know that out of the 24 hours, the water has to be pumped into the community for 14 to 16 hours. Okay, and this storage reservoirs have the capacity to store the quantity of water which has to be supplied in these 14 to 16 hours. Okay, so let us move ahead. Distribution reservoir. The next topic is distribution reservoir. This distribution reservoir provides storage to meet widely fluctuating demand and serve as the balancing tanks. Okay, these reservoirs provide storage to meet fires demands too. Okay, this capacity depends upon variation between maximum and minimum demand, pumping as well as the pumping hours. Okay, so the capacities of distribution reservoir depends on maximum and minimum demand and pumping as well as the hours of pumping. Clear? Usual capacity is 3 to 12 hours of supply. Okay, these distribution reservoirs are classified as surface reservoir and elevated reservoirs according to the position of reservoir. So let us have a look at the functions of the distribution reservoir. First function is that it allows water treatment units and pumps to operate at a constant rate. Second function, it reduces repair, maintenance and operating cost and improves efficiency. And the third function is it helps in maintaining constant pressure. Fourth function is it leads to overall economy. Okay, so these are some of the functions as well as the advantages of the distribution reservoir. Okay, next is location and height of the distribution reservoir. So distribution reservoir should be located as close as possible to the center of demand, right? And second point is that water level in the reservoir must be at a sufficient elevation to permit gravity flow at an adequate pressure. Understood? So let us move ahead. Next topic is the types of storage reservoir. Based on the position, the types of storage reservoir are classified as surface reservoir and elevated reservoir. Let us talk about the surface reservoir. The surface reservoir are actually circular or rectangular tanks constructed at ground level or below the ground level. However, underground reservoirs are preferred for larger size. For example, the tank which is at the water treatment plant is a huge tank and which is underground tank. Okay. These reservoirs are constructed on high natural grounds and are usually made of stones, bricks, plain or reinforced cement concrete. Next is that the side walls are designed to take up the pressure of the water when the reservoir is full and the earth pressure when the reservoir is empty. Okay, why? Because when the water will be there inside the tank, then the water will be exerting pressure, and when there will be no water, then the wall will be surrounded on the outer side by the earth, so earth pressure will be acting when the reservoir is empty. Okay, so the next is the position of the groundwater table is also considered while designing these reservoirs. Okay, because if the water table is high, then the foundation of these reservoirs need to be taken into consideration more importantly. Okay, next is the floors of these reservoirs may constructed with RCC slab or square stone blocks resting on the columns. And to obtain water tightness, that is to avoid the leakage, bitumen compounds are used at all construction joints. Okay. Next is at the top of the roof, about 60 centimeter thick earth layer is deposited and maintained green lawns to protect the reservoir from cold and heat. Okay, so let us now move ahead. So this is the picture of the surface reservoir. You can see over here that at the bottom there is a concrete bed. Okay, they have provided a pipe for draining out if they need to do some maintenance work, right? Okay, and at the top they have provided ventilation for air circulation, and at the top there is a concrete cover. Okay, let us move ahead and talk about the elevated reservoir. So, elevated storage reservoirs, also referred to as overhead tanks, are required at distribution areas which are not governed and controlled by the gravity system of distribution. Okay. Once again, elevated reservoirs are used or are required at distribution areas which are not governed by or controlled by the gravity system of distribution, right? So what will happen is when the water will be flowing through the gravity system by from the water treatment plant, it will be stored in the ESRs, and from there the water will be supplied. Okay, next is these are rectangular, circular, elliptical or sometimes conical in shape. If the topography of the town is not suitable for gravity flow, the elevated tanks are used. Okay, they are constructed where combined gravity and pumping system of water distribution is adopted, and these tanks may be either steel or RCC. Now, RCC is the most commonly preferred tank all across the globe. Okay, so let us now have a look at the accessories of ESR. First one, it will have inlet and outlet pipe, overflow pipe discharging into a drain, float gauge indicating depth of water, automatic device to stop pumping when the tank is full, a manhole and a ladder, and ventilator for circulation of fresh air. Okay, so these are the some accessories of ESR or the parts of the ESR. Okay, so you can have a look at this ESR. Okay, so this is the automatic system. When it will be full, it will cut off automatically. Okay, okay, so these are the topics that we covered in this video. Remaining topics will be covered in the next video.